Hello everyone, thank you for joining this video. I'm Pavel Chaudhary, and to give a brief about myself, I have been working as a professional for quite some time now. The industries that I have worked include transportation, customer and IT success for B2B companies, and edtech companies. So in my journey of software developer and an analyst, one of the most common problems that I have seen is computational problems, which includes both the input and the output in Google Spreadsheets. To deal with such problems, so either we have to directly connect the spreadsheet to Python or import it into Python, do some computation, and then again export it back to the end user to use. It is a seamless effort once it is done on a one-time basis or even twice a day. But what if such task increases to a large volume on a daily basis and it consumes all of your entire time just to do a simple task or a straightforward repetitive task on a daily basis? What if we could directly empower the end user with some function which is very easy to use to them once they have very basic knowledge of spreadsheets, and so that they can directly solve the problem in the spreadsheet itself? And that is where our tool will come in handy. So the objective of this exercise is to create a tool which will empower the end user of a spreadsheet to directly compute niche computational problems which can be directly achieved using few lines of code in Python directly in the spreadsheet. Okay, so the tools which we are going to use to build this is obviously Google Spreadsheet. Then we would use Python as our automation language. In Python, these are the two libraries that we are going to mainly use. Fast API is the library that we are going to use to create an API so that the Google Sheet can interact with our Python code. Shapely package is for a niche computational task, which we will take as an example for this exercise. And for this exercise, I will be using PyCharm as my development tool. Then, to connect that to Google Spreadsheet and to create a custom function, we will be using Google Apps Script, which is very straightforward in its syntax, and it will be really easy to use. And then to put this all in as version control, we will use Git and the deployment of Git in GitHub. And for the deployment environment, we will use Heroku, which is free and very simple to use as well. So in the design part of this tool, we will have two services running. One would be our Google Spreadsheet, which will be used by the end user, and over there we will write our custom function that will interact with the Python code and compute the problem and get the returned value in the cell that is desired. And another API which will be created using Python and Fast API, over where the actual computation will happen, and the response from that API will be sent to the Google Spreadsheet, and the spreadsheet will be populated with the results. So the basic learning that we will get from this exercise is we will get an understanding of how to create simple APIs. We will have an understanding of what version controls are and how to use Git in a graphical manner using GitHub. We will deploy the app that we built using Heroku, so we will also learn a little bit about deployment. Then we will learn about creating custom functions in Google Spreadsheets, and we will lay a foundation for such tasks and such automation to be built for your niche tasks that you're computing on a regular basis. Okay, now coming to the program part. Now I'm in my editor window and I'm using PyCharm as my editor. So whenever you are starting a new project, ideally we should create a new project in the IDE along with a separate virtual environment. So to create a new project in PyCharm, you need to go to Files and then New Project. Then you can give whatever relevant name that you want to put to your project. By default, it will ask you if you want to create a new virtual environment for the project. So usually with each project and each app that you create, you should have a different virtual environment for that particular app, so the dependencies do not clash with each other. So right now I have one of my project already created, so I will not go ahead with this create option. Otherwise, you can just simply write your project name over here, and whatever you want to name your virtual environment as this, create a new virtual environment. Okay, so once your environment is set up, over here you will be able to see your project name and the interpreters that are being used. And in the interpreter setting, you will be able to add packages directly using this interface. So mainly we would be needing Shapely for our computational process, and the example that we're going to take, Fast API, which is the module which will help us to build an API in Python, and the UVCon package, so that we will be able to run this in our local servers. Okay. To add a package, you can simply click over here and type the name of the package that you want to install and click install. Otherwise, you can go to your terminal and write pip install commands as well. We will also include a requirements.txt so that you can directly install this requirements using pip install -r requirements.txt. Great. So the example that we are going to take for this automation is kind of related with geospatial data. So there are many formats of representing geospatial data. One which is most common is in pair of latitude and longitudes. So if you want to define a place, you can attribute latitudes and longitudes directly to that place and locate that. So we call that a point in geospatial terms. So this is an example of a point. Write it this way: point in brackets latitude space longitude pair. But this format, this representation of a point in this format is kind of difficult to store and process. So usually in most of the databases, we store that in a WKB hex format, which is quite easier in terms of storage, as it does not include spaces, and it can be directly decoded as well when you are using this in a program. So suppose you want this string to be decoded and get uploaded in your Google Sheet in this format. Okay, so this is the problem that we're going to solve. We're going to create a custom function which can be directly used in the Google Sheet itself, so that it will be able to decode this string to a WKT format. This is a WKB hex, which is called a well-known binary in hexadecimals, and this is a WKT, which is a well-known text. Okay, great. For this basic example that we are going to take for this automation, let us quickly see how it can be done by quicker and simpler lines of code. So from Shapely, we will import WKB class, and we'll create an object from this class using its loads method, and in it we will pass the string which we want to decode, and we will say that yes, it is a WKB, and we will simply print this. Okay, got an output which is a presentation in WKB. So this is just a simple example for this exercise and for this automation to build, which we will use as a template for other further automations of such kind. Since this is going to be a repetitive task in the program, let us convert this to a function. And this function will take a string as an input and will return a string as an output. Okay, and in this function we will use the same logic that we have used over here. Let me paste that and name this as out, and this would be the string that I receive in my input. and in the output we will just return and in the output we will just return the string of the object that is created using this function. Okay. So to see this in action, we will create a section of code in which and over here we will perform this task and put this in my input. Let's format it a little bit. I'll remove these things and press Shift run. Okay, so now the program has run and our function is working, and it is also able, and we have tested it. Now let us proceed towards creating an API. So for this we will import from fast API, import fast API class. This will help us to create an API or instance, and we will also need a model builder called pydantic base model. So this will let us define our own data types and let us create a data model in which we can fit the input parameters. Okay. So once this is done, we will extend this base model class and create a new class of our own. We'll name that, say, WKB hex. Okay, and it will get extended from this base model. And in this WKB hex, which is essentially the data format of our input, we just have a string, right? So we'll create a variable called WKB hex, and it will be of type string. Okay, so if you're not familiar with this kind of syntax in Python, this is called annotation, and with this, in functions and in class definitions, you will be able to specify what is the data type of the variable or the output of a function, which is kind of a helping tool in understanding what the function takes as a data type and what is the output of the data type. It does not affect your code. It's just something similar to a comment. Okay, so you have created your data type, you have your function in place. So now let us proceed towards the endpoint create part. So we will create a post endpoint. So over here you will be able to send your input via post method and get the output as a response. So this is called a decorator in Python. So decorator takes a function as an input, adds some extra functionality to it, and returns that. Okay, so the decorator is written as an @ symbol, and it is already coming from this fast API base class. Endpoint for this use, we will name this as get wkt from wkb. So when you're creating an endpoint, it is recommended that you use hyphens instead of underscore or spaces. That is how the entire kind of web is built. Okay. So once it tells us that once you hit this endpoint in my domain, this is what you need to do. You need to call this function, and we are creating a function which will get called whenever this endpoint is hit with an input. Okay. So this endpoint will take an input which is of the data type that we built right now, called WKB hex. Okay. WKB hex. Okay. And once you get this data from the input via web, you need to run this statement and return the output to them. Okay. So I will So we will return the result from this function of this data model. So you have created a class. In that class, it has an attribute called WKB hex, which is the actual input that you need. Hex. Okay. So once this is in place, whenever you hit this route with a post request and your input contains a WKB hex in a string format, we will get the WKT from this conversion logic. Okay. Now to see this app in action, let us go in terminal, and now we are going to use that ubicon package that we have installed, and we will write ubicon. We will specify the name of the app or the file that in which the app is written. In our case, it's main.py. So we will specify in this directory, search for main file, and in this app or file, find this object. Okay. So once you find that object, run this in this host and open this port for it. Okay. So essentially this 0.0.0.0 is your local host, that is your computer, and we are listening to the port 8080 of your computer. So once you click enter, it will start a local server in which your app is deployed, and you can have a look at it in your local web browser. So we'll just create another tab and go to this port and go to its docs. Okay. So in Fast API, it's kind of easy and handy because over here you will be able to see the documentation of the API that you created, and it's a self-generated documentation. So we have a Swagger OpenAPI documentation at an endpoint called docs, which is already auto-created, and a redoc documentation in their endpoint called redoc. Okay, so for now we'll just stick to the basic Swagger doc. And over here you can also play around and test your API. So we will go in this tryout feature, and we will use the input that we were using out there. Put this in the string and run execute. Okay, so this is the curl request that it has sent, and this is the response that it got, okay, as a string. Okay, so the first step of deploying an app is to list down all the dependencies that you have in your current interpreter, so that once you try to replicate this entire process in some other server, there is no dependencies issue over there. So for that, we will write pip freeze into requirements.txt. So what we will do, it will freeze or list down all the dependencies that I have in my requirements.txt file in this folder. So let's run that. It has run, and it has updated my dependencies over here, and whatever dependencies I have are listed over here. So by default, if you do not have this file created already, it will auto create this. So let's kind of delete this file once, say, and recreate this, and you see it's got populated over here with all the dependencies that I need. Okay. The next step for deployment is to create a proc file. A proc file is a set of instructions which will be used by your cloud platform, and it states the cloud platform that once you're starting the app, this is what you need to run. You need the ubicon module to run my main app at this host with some port number. It's kind of a standard notation, and it kind of varies from the platform to platform. So for Heroku, this is how we create a proc file and the standing instruction for deploying an app. You can directly use this in your app as well, and you can alter the port number if you want, but usually this is what is kept everywhere. Okay, so our program is ready. We have a main file in which all the logics are built. We have the block file, which will be used by the deployment cloud platform. We have the readme.txt, in which overview of the entire architecture is written. And then we have requirements.txt, which lists down all the dependencies that we have. The next step of this automation is to somehow control every code that you write in a version control system. So for that, we will use GitHub. So let us move towards deploying and putting this in a version control in GitHub. So for that, you can go to any browser, search for GitHub, and log into it. If you have already an account, then you will be able to log in. Otherwise, the sign up is kind of straightforward. You need to create an account using any of your email IDs. You need to verify that, and it will take you to the GitHub homepage. Okay. So over here we have repositories, and each repository is a set of codes that needs to be put together. It's kind of a folder in our daily storage systems. So to create a new repository, you can click on create new repository. So ideally, each program, each automation that you create, you can put them into a single repository and dedicate one entire repository to it. So you can write any name to it, and name. You can add description. You can set the visibility of your repository. You can add a sample readme file. You can add a git template, git ignore file. So the git ignore file tells the git to ignore some files which you don't want to upload, or you don't want to get controlled in the version system, so that you can specify in the git ignore files. Okay, then you can choose any license. For now, I'm not choosing a license, but there are multiple licenses. You can go over the details of them and choose appropriately, and you can then create a repository. Okay, so for now I have one repository created, and it's a public repository. We will share the link with you as well. So all you need to do is click on this add file, upload files. Then you can either drag the entire files from your system, or you can choose the file that you want to upload. I'll quickly choose the file that I want to upload, and I will go to. So these are all the files that I want to upload. Okay, and I will open them. And over here you can add some commit note. So a commit is kind of a checkpoint for your codes. So if you want to come to a previous checkpoint in which everything was stable, you can roll back as well. So I will just add some random command right now. Adding as for sheets, and I will directly commit this to a main branch. Okay, so the next step of this automation, once you have your codes in a version control system, is to deploy this in a cloud platform. So for this, we will be using Heroku, as it's free and kind of easy to use. So you can directly sign up to Heroku, and the sign up process is again straightforward. You need to provide your email and verify that. And once that is done, you will be able to create and deploy apps over there. So once you are kind of logged in to Heroku, the platform that you will be seeing is something kind of this. So you'll have all the dashboards in which your app are there, and in this dashboard you will be able to create new app using this new button. All you need to do is create a new app. You can provide any name to your app. So for now I will use this name that I have picked, converted WKB to WKT. I will choose the region as United States only. Add to pipeline, we do not need to do that. And we need to create a app from here. Okay. So once you're into this, it will ask you, how do you want to choose this pipeline, or the deployment method that you're going to use. So we'll be saying that we are going to directly use our codes from GitHub. So now it will ask you to connect to a repository. So I will start typing my repository's name over here and ask it for search. And over here I get the suggestion of my repository. So I will ask it to connect. Okay. So now there are a couple of questions that it will ask. So do you want to automatically deploy whenever there is some change post to your main branch? So yes, I want to do that. Okay. And for now, which branch do you want to choose for your deployment? So I now have only one branch, that is main, so I will use that branch for my deployment. Okay, so now it's building the app in their platform, and once that is done, they will give us a URL in which our app will be accessible across the globe. Okay, so app is built and it is successfully deployed. So we can view our app and go to its docs. Okay, here's a similar interface that we saw in our local copy. To test it out, we'll just pick the input that we used over there, try it out, raise the string value over here, execute, and we're getting a result properly. So the next step, once your web app is deployed, is to create a custom function in Google Sheet so that we can directly interact with this API and get the computation done in Python and get populated our cells directly in Google Spreadsheet. So for that, we'll go to the spreadsheet, we'll go to extensions and click on app scripts. And once you are in the app script editor, you will be able to create custom functions which can be directly used in the Google Sheet. Okay, so for that, the notation to create a custom function, start with a function statement, and after that you can specify a function name, which by practice is in all capital letters. So by the way, this language that we are going to use is called AppScript, and it's kind of similar to JavaScript, but is syntactically kind of readable as we are coming from a programming background. Okay, so this function will take an input of text type, or the variable name is text itself, and once we have this variable, we will post a request to this URL, which is essentially the URL of our app. Okay, this is the URL that we're going to post to. Okay, so after that, we will prepare our data in a JSON format or a dictionary format. So remember, we had used WKB hex in our program, in our data model over here. That is how we want to specify this in this tab as well. Okay, so over here, the key name is going to be WKB hex, and the variable that is taken as input will be the value of this key. Okay, and these are a few options that specifies how the request would be. So the method of the request will be post. The content type that we want to send and get is going to be JSON, and over here we are making a string of this dictionary so that it is parsed or easily passable directly via web. Okay, and in this line we will first send a request to this given URL with these options, and this is the syntax for that. URL fetch app. Okay, so once we get this, we need to get the text out of it, because that is in a response class format, and we are going to try to extract the text part of it. Once that is done, we'll parse the JSON and get the value in a variable called wkt, return the value. So what this function in total essentially do is it will take an input from a cell, and whichever cell you're writing this function to, it will write the output from the program, and in our case that is conversion from WKB hex to WKT in that very cell. Okay, and these are comments. These are kind of suggestion strips which will come underneath the function name when you start typing this in the Google spreadsheet. this kind of template that you can extend or use in any of your app without changing much in the code. If you want to add multiple inputs to your function, then you need to just specify the name over here, input 2, and directly use that in your API. Okay, like this. If you have field in your API that you can take 2 or more parameters, this is how you're going to specify that. So once this is done, so let us go to the Google Sheet to see this in action. Okay, I will come to the cell. I will write WKT from WKB. This is a suggestion strip that is coming underneath, which is coming from here. Okay, I'll just simply click on it, select the cell, close the brackets, and I will get the result from the API that we have just built. Okay, now once this function is built, the API is deployed, you are free to use this function any number of times anywhere in the spreadsheet. So they say these are the values that I have. I can simply extend this function as any regular Excel function, and it will get the details from the app and populate it over here. Okay, so for completeness sake, we will add this file as well in the GitHub so that it is easily available to anyone who is looking at this repository. Okay. So with that, we have the automation in place in which any task which needs Python intervention can be directly completed in the spreadsheet itself with simple custom functions created using Python API, and which can be scaled up to any number of times, and anyone who is familiar with even basics of spreadsheets could utilize the potential of Python functions in the spreadsheet itself. Okay, so one great example of this could be if you're running surveys via Google Forms on a regular basis, then you might be getting feedbacks on these forms or any comments, right? So you can run a sentiment analysis on those feedbacks directly in the spreadsheet itself without even going to Python. You just need to create a route which has the function which analyzes the text and returns back the sentiment of the text, and you can get that populated in the spreadsheet itself. Okay, let's cover that automation in some other future video. Till then, thank you for joining, and goodbye. Take care.